A very good day to Dr. Shamila and my friends. My name is Cheeh Hui Min. Matric number is 271917. Today, I will present my individual assignment for subject SQQM1034 Calculus 1. In this assignment, there are two questions need to solve. For question 2, the question will be answered in handwritten form. For question 1, I will present the solution through this video. So, let's move on to the question 1. For question 1, the question is discuss and sketch the following function, which is f function equal to x power of 5 minus 8x cubed. There are some hints that before we find the x-intercept, the domain for the f function is x equal to intercept with any real number. So, to find x-intercept, let fx equal to 0. The x-intercept is origin, square root 8 is 0, and negative square root 8 0. To find y-intercept, let x equal to 0. So we put the x equal to 0 into the f function, and the y value equal to 0. So the y-intercept is origin, which is 0, 0. To find the upper interval where the f function is increasing or decreasing, we use first derivative test to find the critical number and let the f prime function equal to 0. And the critical number, which is x equal to 0, positive negative square root of 24 over 5. And the upper interval is the following answer. Next, to find x coordinate of the inflection point, we use second derivative test to test the inflection point and let f prime x equal to 0. And the x coordinate of the inflection point is 0 and plus negative positive square root of 12 over 5. And then the upper interval is the following answer. Then we combine the upper interval from the critical numbers and the inflection points, and the upper intervals is the following answer. Below is the answer for the upper interval where the f function is increasing or decreasing and concave up and concave down. For the first derivative function, if the answer for the first derivative function is greater than 0 or positive sign, it is increasing. If the answer is smaller than 0, which is negative sign, it is decreasing. For the second derivative function, if the answer for the second derivative function is smaller than 0, it is negative sign, the function is concave down. If the second derivative function is greater than 0, which is positive sign, the function is concave up. Then we use the number line to roughly sketch the graph. The first interval and the second interval is concave down. The third interval is concave up. The fourth interval is concave down. And the fifth and sixth interval is concave up. Next, we sketch the graph. Before that, we have find the x-intercept and y-intercept. To find the critical points, we find the value of f function when the x equal to positive negative square root of 24 over 5. And the critical point is the following answer. To find the inflection points, we find the value of x when the x equal to positive negative square root of 12 over 5. And the inflection point is the following answer. So, we have already the x-intercept, y-intercept, and the critical points and and the inflection points, and we can use the points to sketch the graph. Below is the graph for the f function. From the graph, it shows that the local minima is this point, and the local minima is this point. So above is my presentation for this individual assignment. That's all from it. Thank you.